Welcome to another exercise in the workbook statistics. This time I'm going to talk about an exercise where we're going to perform a test to compare a mean to a test value. So let's have a look at the exercise. Here we have a company produces neckties with a standard length of 50 centimeters. The production machine, however, does not produce perfectly scaled ties. The length is normally distributed with a standard deviation of 0.76 centimeters. In the context of a quality assurance study, the following lengths for neckties are measured. And we have here, as a result of this measurement, 10 different values for neckties. Our task now: can, assuming a margin of error of 1%, be assumed that the machine deviates significantly from the target length of 50 centimeters. Before we start with this, we have to perform a test for comparing the arithmetic mean of this sample with the given test value of 50 centimeters. But we have two possibilities for the test. We could use a Gauss test or we could use a t-test. Since we have an information on the standard deviation here already, we could use the slightly more simpler version of the Gauss test and do not have to calculate the standard deviation. So with this in mind, we can actually turn to our first calculations. So as an arithmetic mean, we're simply going to add up all the values, divide them by the number of observations, yielding us a result of 50.2 centimeters. That's the value we're later going to compare with the reference value, the test value of 50 centimeters. We also know the variance or the standard deviation. So this one is given here. So the only thing missing is our reference statistic, or rather reference statistic, our quantile of the respective distribution. Since we already know the variance, we're going to use the Z distribution, the normal distribution here. And for this respective test, which is a two-sided test, since we could deviate upwards, neckties could be longer, or we could deviate downwards, neckties could be shorter than they're supposed to be. We're going to use a two-sided test, which means here we look up the Z value for 1 minus 1/2 alpha. Alpha, that's our margin of error. Here we said the margin of error should be 1%. So we're using 0.01, getting as a result of Z 0.995. This one we could look up in the table for the quantiles of the Z distribution or the normal distribution, where we can find a value of 2.5758. So that's our reference statistic or reference value we're going to use in the test on the next slide. Here I just summarized all of our previous results: the calculated arithmetic mean, our standard deviation from the exercise, the Z distribution quantile, the number of observations, and the test value. So in the next step, we're going to calculate our test statistic, which here is relatively straightforward as the square root of the number of observations. So we're using the 10 here. The difference between arithmetic mean and test value, so here 50.2 minus 50, divided by the standard deviation, which we already have from the text. Doing this yields us a result, a test statistic of 0.8322, which in the next step, in the test decision, we're going to compare with this reference statistic, with this quantile of the Z distribution. Comparing the two values, we see that our test statistic is definitely smaller than the reference statistic. So this means we cannot reject our H0 hypothesis. This means there's no significant difference between these two values. This means, transferred to our original text, the sample does not significantly deviate from the target value, so the machine works within reasonable margins of error. Well, that's then everything there is to this exercise. I hope you enjoyed it. I say goodbye and see you next time.